Okay, good afternoon to everybody. I see that you have survived lunch. That's always good. My name is Ophir Arkin. I'm the Chief Technology Officer of Insidix, and I'm here to speak today about next generation infrastructure discovery. If you look at any IT initiative that we want to deploy throughout our internal network, then without having complete, accurate, and continuous information about our IT infrastructure, any of these IT initiatives are deemed to fail. This is because we must have infrastructure information, contextual infrastructure information about our infrastructure in order to use that to defend and manage our networks. There are a lot of people here that talked about building walls and more walls around our environments. If you recall from yesterday from the keynote, the guy that I don't remember his name that was talking about, let's put less walls out there. The problem is that when you want to put a wall, you need to know what it is actually defending. Why are you going to put this wall? What's the cause for it? Is it actually something that does its job? Unfortunately, many people forget that the first thing to do before putting any walls is to understand what do we need to protect. And for most of the cases, along the years, many researchers have tried to solve the issues of knowing what is on the enterprise network, who is doing what on the enterprise network, and of course what is being done on the enterprise network. But as I will demonstrate, unfortunately, all of those researchers have failed to answer the questions in an accurate and granular and complete manner. So what we'll be doing today is we're going to go through the strengths and weaknesses of active and passive network discovery, and then we will introduce a new agentless real-time approach for infrastructure discovery, monitoring, and auditing that provides contextual, complete, and accurate information about the IT infrastructure in real time. A bit about myself. As I said before, I'm the Chief Technology Officer of Insidix. I'm also the founder of the Security Group. Some of you might know me from my previous work, XProbe 2, Voice over IP Security. I'm a member of the Voice over IP Security Alliance. And I usually doing either infrastructure discovery work, voice over IP security, or information warfare work. For those of you that will be coming to DEF CON to March 11, I will be releasing a new version of XProbe 2. So, nifty tricks with Keynote. If we look at the enterprise networks, then they're huge, they're dynamic. They contain usually several networks in different geographical locations, and there are a variety of systems that are actually located there. Some of those systems we know, some of them we don't, and for some of us we'll never know about. The problem is that some of those systems are critical for us. We need them to be available to be used, and their unavailability might cost us not only with financial damages, which usually is associated with breach talk, but also would prevent us from doing our day-to-day job, prevent us from actually working. The interesting thing is that mission critical is a definition that is different for different people. In the early days when I did network security, I was thinking that mission critical is servers, might be the network devices themselves only. But at the end of the day, I think that desktops are mission critical, and I think that whoever suffered from one of the blaster variants understands that desktops are mission critical because they can bring other mission critical systems down and actually call the network. So if we look at the regular operation of an enterprise, then it relies on a number of different variables. We need our networks to be available. We need our links to be available. We need to have the elements residing on the IP network available to be used, and we need those elements to operate and to function correctly. And of course, we need to defend ourselves, and we need to defend the corporate assets. Basically, this slide says that we need to do networking, we need to do security, and we need to do management. So before we even start to speak about security, before we even start to understand and to do networking job, we need to first to identify what are our assets. We need to understand what are the properties, what are the different interdependencies between them, and actually understand what are the roles are. We also need to determine what's the importance of those assets for us, and of course, for the business process. And I'm saying that because the business process at the end of the day is the one that will give you the check to buy a system or not. Because if that is being affected, then nothing else matters. And we need to provision those systems, and we need to know how they look like, and we need to be familiar with them, and we need to provision the network, and we need to understand how the network looks like. And we need to detect and troubleshoot any issue that arises. And of course, we need to understand if there are some network elements that pose some risk to the network, and to react immediately. At the end of the day, there are a lot of issues that we need to take care about. And of course, our main and foremost problem is that in order to manage and to secure the IT infrastructure, we need to gather information about our infrastructure. Without that context, without understanding what we're defending, then there is no chance in the world that we're going to do that. So what kind of information do we need? We need information that basically shows out our network, means topology. We need information about the different network resources. And of course, we need information about the elements themselves that reside on the network. Without this kind of intimate, complete and accurate information about the networking environment, there is no chance to do management or to do security for the network. The main problem with this kind of information is that usually this information is not available. Why it's not available? Because sometimes one guy in our corporate, two guys in our corporate completely controls this kind of information. They leave the corporate, and the knowledge also lives with them. Sometimes this information is not easily produced in Orville. Sometimes elements are very dynamic, and they constantly change some of their parameters. For example, they use DHCP, they connect sometimes from the network inside, sometimes they use VPN, sometimes they come and go. And of course, the biggest problem is that we use technologies that at the end of the day are inappropriate to provide us with this information. So all in all, the unfortunate result is that the inability to know the internal network takes us to the stage that whatever walls we will put, whatever management that we'll try to do, it will never help us. Because we'll always work with the 80-20 rule. And when you work with the 80-20 rule, and it's your internal network, you always lose. I was a chief security officer for several companies. The last company I worked for, my CIO on my first day of my job, I asked him, okay, so what does my network diagram look like? And he took a pen, and this is a real story, he drew a circle. And inside the circle, he drew a question mark, and I had to work with this. And I was a chief security officer. So I had to go and I had to map the environment myself. I had to understand what I have. And I basically was doing work that had to be done 5-6 years beforehand. Try to baseline what the company had. Starting from routers, going to switches, understanding how everything is laid out. At the end of the day, I lost. I lost the battle because I wasn't aware of changes on the network. I wasn't able to receive them in real time, and I wasn't able to associate events that had happened with other events on the network. So whatever I tried to do, I lost. And I was working with the 80-20 rule, meaning that I'm unable to have everything, but I need to work with what I know of. And sometimes this is something that chief security officers work, like for example, they have some kind of fire, they will try to put some, to take the fire out, and they continue, instead of understanding that in order to solve the problem, they need to do something else. At the end of the day, when we work like this, we have a full sense of security, and we don't have any kind of control for our environment. And this is something that is definitely no-no when it comes to security, and of course comes to network management. I bet that some of you had been into rooms that they had discussions with networking teams, security teams, and those guys that do an application, and they were arguing about who's to blame because the network is slow. And this is just an example of why, when not having the right contextual information, can do really nothing solving the issues. So the current network discovery technologies simply cannot deliver what we wish. But let's try to define what is a network discovery system. I define it as a system that should perform the discovery of the network topology and should also discover the elements that reside on the network, their properties, and to maintain this information up to date. It seems, it's a 3.5-line definition. It seems okay, right? It's nothing big, but unfortunate. As I'll show you in a few slides, active network discovery, and especially passive network discovery, cannot deliver this. And all they can have is to have inaccurate information and incomplete information about the networks they deployed on. So let's start with one of my favorites, active network discovery. Basically what you do is you send packets to the network, you wait for some kind of a reaction from a device. Sometimes you are looking for a lack of reaction, and then according to what you get back from the probes that you send, you draw conclusions about the element and the network. So if we look at the information that we want to extract using an active network discovery system, an ANDS, then we need to take the inventory of network elements. We need their properties. We want to have information such as active network services and their versions, some configuration information. Of course, we want to have the topology of the environment. And some of those active network discovery systems also do some vulnerability assessment, although not all of them do. If we look at the network diagram, then the circled element is the active network discovery system, scans the network from one point. There are other systems that can do multi-point to multi-point, but at the end of the day, there are some ways to use ANDS. Some ANDSs, you feed the ANDS with a list of IP addresses or some network classes, and the ANDS goes and just discovers what's there to have. Sometimes the ANDS will work only against the local network it is attached to, and in some other cases, for example, HP OpenView and other tools like that, an ANDS will try to extract information from routers on the network, to extract information about the routing table, to understand if there are other networks it needs to operate against, and will work in a semi-automatic manner. The strength of active network discovery comes to only a single slide. Basically, we can control what we scan for. We can control the parameters that we need. We can control the initiation of the scan. We can control the pace of the scan, which is very important. And at the end of the day, we can cover an entire IP address range of an organization, and of course, if there are no network obstacles between the scanning system to the target. The weaknesses are more interesting. We will only detect network elements that are operational on the network. It means that they need to be up at the time of the scan. They need to respond to our probes. And of course, if there are no network obstacles between the sending machine to the target. Network obstacles such as network firewalls, host-based firewalls, load balancers, NAT devices. Wireless access point is another good example, but because it will, if it's a wireless access point which also performs NAT and firewalling, it will not let you understand what are the devices at the other end of the wireless access point, which are the devices that are connected. And at the end of the day, what you'll see is only an incomplete list of elements that operate on the network. From a network that might have this list, it will show you this list. A good example is Windows XP Service Pack 2, which has firewall enabled by default. I had read a very interesting white paper from one of the active network discovery systems vendors. This basically the white paper said, if you want us to discover your Windows XP SP2 machines, please open at least port TCP 139 so we can speak to the machine and we can understand that it's there. It doesn't usually work. An active network discovery system depends on enumerating information from several services that needs to operate on a device it is querying. If the device does not have this port open or service open, or the device is not willing to communicate with the active network discovery system, then this kind of information will not be able to be extracted from the device. There are several examples for that, like SNMP if you don't have the community string, or if you don't have the rights, or if SNMP is not working on the device. Of course, another example is the Windows Remote Registry Service. Another major problem of active network discovery is the fact that active network discovery is not being done in real time. It's slow, it's time-consuming, it sends a lot of packets to the network, it takes a lot of time to process what is being brought back from the network and to show that to the user. And at the end of the day, it only produces a snapshot of a network and its elements at a certain point of time. The nice sound effects behind me. Another major problem with active network discovery is that it sends a lot of traffic to the network. It sends a lot of traffic to the network from one point, and it consumes a significant amount of network bandwidth. Now, this might cause network degradation. You will see a slowdown in the network while the scan is being done. And also, another side effect, it might also affect the networking devices that are on the path between the scanning system to the targets, because now they have to process more packets in their queues than the usual, and sometimes the amount of traffic that they would have to process will be much more than they can handle. The amount of network bandwidth that an active network discovery system consumes is a direct effect of the number of IP addresses that needs to be scanned, and of course the number of queries per IP that needs to be sent. All in all, it's a large number of packets needs to be sent out and consumes a lot of network traffic. Sometimes people say, okay, if I know that the process is long and if we know that the consumes a lot of network bandwidth, let's move the discovery, let's move the active network discovery to off-peak hours. But guess what? Off-peak hours is a nice definition, but nobody can actually put the finger and say, okay, this is my off-peak hours. If you are an enterprise that works 24/7 and you have workers working around the clock, then there are no off-peak hours for you. Sometimes during what you term as off-peak hours, you have other important processes that kicks in, and processes like backup, processes like offline processing of reports and things like that. Then sometimes the process takes too long to be run at those off-peak hours, and it gets to the point that running these kind of scans through the off-peak hours gets also done on times that people come back from home to work again. One of the telcos that I know perform active network discovery only once in a month, because it takes takes that telco 2 days to run active network discovery across 4,000 devices. Then sometimes it looks like a very long time, but there is another caveat to running a faster scan. If I scan faster, it means that I send more packets per second. It means that I send more packets to the network. And it then means that I might be able to overwhelm the networking devices along the path between my system to the target. And it means that those devices might either drop packets or crash if I overload them. And this is, of course, another effect when you scan a large number of IP addresses. Another nice side effect of doing active network discovery, if you're not doing that right, active network discovery might also crash the end devices that it needs to gather information about. If I take, for example, how many of you know Nmap? Oh, good, you're not totally asleep. If I take Nmap and I scan, I have at the office a Kyocera MIPA FS 1900 printer. If I use Nmap and scan the printer, I'll go and have to reset the printer. I have to just shut it off and shut it on again, and put it on again. Simply, there are some tools out there that crash legitimate endpoints. Why do they crash it? Because sometimes the pace of the scan is too much for that endpoint to handle. Sometimes the endpoint is old and its spec is not something that that company would like to be proud of. Sometimes the type of the pubs are non-RFC compliant, and therefore what they will cause is they will crash the TCP/IP stack because it has unexpected input. Also, in some cases, people say, okay, I'll do network topology by pulling the information, the ARP table from the router. That's a very bad thing to do. Most of the routers can't take it, and most of them crash when you do that. Some people just don't make sure that when they do vulnerability assessment, they just don't remember that they don't need to use the type of attacks that might kill their servers or kill their workstations. So from time to time, part of the network goes down because they kill the switch, they kill the router, or they kill the major server when they do so. Sometimes what happens during active network discovery is that the network devices are overwhelmed by the traffic, but it doesn't only ends with regular networking devices. Some firewalls, if you try to scan through a checkpoint firewall, it will build the entire state table, it will fill it in, and legitimate traffic will not be able to go through the firewall. So there's like a lot of effects when you do active network discovery. So people had looked at all of those problems, and then they said, well, you know what? I'm so afraid to use active network discovery, so I'll take some of my networks, and I'll talk to my security guys, and I will not have them scan those networks because my production machines are there, and I'm not willing to suffer any kind of downtime with those machines. And this creates what we term as active scan-free networks, those networks that you cannot scan, and at the end of the day, you are unable to understand what their state of security and what the contents of those networks. Questions? Anything? Wow. Okay. Distributed active network discovery. So, in order to try to remedy a bit of the problems, some companies are using two ways to deploy active network discovery. Active network discovery clusters and proxies. A cluster, basically, is many machines located in the same place, and they share the load of the scan from one point. This actually has no real effect because has no real advantage, actually, because the network is still scanned from one point. The network is, well, it might get saturated faster, and also there is a higher risk of instability because of scanning faster. More packets are sent to the network. The elements between the scanning system to the end devices might get saturated faster, and at the end of the day, it might even not speed the scan itself. If you look at proxies, then proxies are actually deployed throughout the environment, usually at each subnet or at each logical broadcast domain. They require that we'll have a pre-knowledge about the network in order for us to deploy them in the right places. Sometimes organizations just do not have this kind of knowledge and they're unaware of how many actual IP address ranges they have. There is a real advantage to doing proxies because the scan will not go through routers and usually will not go through firewalls. The scan will be faster. But there are also problems with it. It's not just that we need pre-knowledge about our environment, it's also that if we have IP address ranges that we are not aware of, they'll still be remained unknown. So, this first part was about active network discovery. And it seems that you are all asleep after you had lunch. Any questions? Yeah.
I'm just curious. You have a successful white paper on active directory scanning issues, more detailed material.
But of course, if you go to the website of my company, www.insightix.com, go to the white papers. There are 2 white papers there. They are referenced at the back or at the end of the talk. One of them discusses the risks of using passive network discovery, and one of them discusses the problems with active network discovery. Yes?
Have you ever looked at using just simply ARP to identify companies that are
ARP is nice, and it means that you have to be on each broadcast domain, and networks are more complicated than that. Also, you want to understand. You want to automatically discover all of your IP address ranges. And that's a bit of a problem if you have a system installed on one of the ranges that you already know about. This is usually the problem, let's say, if I want to put an agent on a system. Where would I put the agent on? On systems that I know, right? But what about all the systems that I don't know of? That's again the 80-20 rule. I might put that against 80% of what I know, but the other 20% that I didn't have an idea about, that poses the risk to my organization. Other questions? Okay. Passive network discovery systems. Their roots goes back to the mid-1990s. Don't let anybody tell you that they were invented last year. Passive network discovery is merely a sniffer which is installed at a choke point on the network and processes packets it can see from active user and network activities. Passive network discovery can be deployed in many manners. I'll show 4 different slides of how you can do that. You can hook up to the network using a network tap. I'm not going to recommend it, but this is something that you can do. You can hook up to you can hook up to a switch that is able to provide with a span port or a mirror port, and you need to make sure that traffic that goes through the span port does not take the switch down, because the switch doesn't have enough bandwidth. It can have enough bandwidth in its backplane that it can share. Try to do that on a 2950 Cisco. That's not a good thing. You can put passive network discovery at each access layer if you have the budget, and you can span multiple ports and traffic to a single machine as well. So the type of information that we can extract using a passive network discovery, it seems as with active network discovery, but there are some twists here. We can have inventory, but inventory only of active network elements. We can have network services information and their versions, but only about active network services. We can have topology information, but the topology information is actually the distances that the systems that we have detected are from the monitoring point. And we can detect client-based software and their versions. We can have granular network utilization, and we can also, in some cases, identify vulnerabilities, although not in a complete manner. So if we take all of this information, wonderful information that has a real value, we can build the layer 3 topology of the organization. We can try to at least. We can have some audit capabilities. We can provide with network utilization information. We can also use the system as a network forensics tool. We can do vulnerability discovery, and we can take some context and to feed it into other tools. So, what are the strengths of passive network discovery? It's real time. The system broadcasts something, it's being detected. Something is being done on the network, it's being detected. A very high value, a very important strength of passive network discovery. The system, a PNDS, does not have any kind of impact over the network, although if you misconfigure your switch and you turn too much traffic into the span port, try not to overwhelm the backplane of the switch. Then there are some interesting stuff that can happen to you from my own experience. Also, this does not pose any kind of risk to the stability of the system, of the network, because you don't send anything to the network. And of course, it gathers information from all TCP/IP layers and can detect any activity on the network, if it's for a short time period, if it's for a long time period, whatever that transfer traffic to the network or receive traffic to the network, you're able to see it. Passive network discovery can detect active network services, whether they're operating on their default ports or whether they're operating on non-default ports. It can detect client-based software, and of course it can detect elements that are operating behind packet filtering devices. For example, firewalls can detect not enabled devices and so forth. If an enterprise has active free networks, then those passive network discovery systems can work there as well, because they don't query anything, so they don't pose a risk to those networks as well. Until now, we have seen the part that I guess many of you have seen before, the praises for a passive network discovery system. But a PNDS has many weaknesses. The main problem of a PNDS is that what you see is only what you get. It means that a PNDS cannot draw any kind of conclusions about anything if it doesn't see the appropriate traffic. If the traffic does not go through the monitoring point, there are no conclusions that can be made. It also means that sometimes a PNDS might wait for an information, for some type of information that needs to be sent in order to draw conclusions, but that type of information will never be seen, and the type of information will never be gathered, simply because the user didn't want to use something. A passive network discovery cannot detect idle services, elements, or applications, because until now I don't know of any kind of a telepathy servers that can do this. This is why a passive network discovery system can only provide with partial, incomplete information about the network and cannot detect in any way all of the elements that are operating on the network and their respective properties. So as a summary, and I like this part a lot because I've seen these 4 lines that appears on the top of this slide in a marketing slide for a tool. Passive network discovery cannot detect all assets. Passive network discovery cannot detect all protocol services, and of course it cannot detect all ports. The quality of the traffic that will be uncovered depends on the activity that the host and the network will do. And of course, there is no control whatsoever about the type of information that will be discovered. So basically, I have this wonderful tool that has many nice things that I can do with, but at the end of the day, it doesn't give me completeness. It doesn't give me granularity. It can give me other things that are interesting to maybe other security tools. It can be used as a security platform, as an audit platform. But at the end of the day, if I'm looking after a complete network discovery and understanding of what I have, this cannot provide me with that. Of course, there is no control of the pace of the discovery. I'm not sending the stimuli out. I am not sending anything. I cannot say to a user, okay, you use your system now because I need to discover it. The IP address space that will be discovered will also be limited. because, again, what I see is what I get. And there are some issues that cannot be uncovered passively. And if you are interested about those, you can go and download my white paper. You'll have more than a dozen of examples of what you can't really determine about an element. Another one of my favorite weaknesses is that the inability to provide with network topology. Now, a passive network discovery system looks at the traffic and looks at the time to leave field value and understands the distance a certain element is from the monitoring point. This is very nice, and it means that an element that will be detected, we can put him in some place relevant to the monitoring station. Unfortunately, for a passive network discovery system, it cannot detect the layer 2 architecture, and it is also unable to talk to switches and ask them which are the systems that actually connected to the switches. Also, routing which is done not through the monitoring point, routers that operates but are not detected on the same broadcast domain or IP subnet. And of course, since we are not able to discover all of our assets, then the information will be partial. This is an example. Let's say this is our test network and we have a passive network discovery attached to a switch, and it sees all the traffic that goes through the monitoring point, and the terms are more than enough to detect those. This is the actual, and this is what the PNDS will show you. Again, actual, I guess that this is nothing that you think that it's actually there. There are no switches whatsoever. The router is identified, that's fine. You don't know where the devices are, which devices are connected to where. And of course, you have ghost switches in through your environment. In order for a passive network discovery to have an effect, a passive network discovery needs to be deployed closer to the access layer. As a rule, anything in security and management that you want to enforce needs to be deployed as close as possible to the access layer, and sometimes it needs to be in the access layer itself. One of my favorite examples is from my telecom days, where some of our ISP users were infecting other ISP users through the cable network. What we did for them is only termination for the authentication, but what had happened is that they only wanted, if we even blocked them access from the ISP when we understood that they are infected, it would still use the internal cable network, and what we have seen is that 1, 2, 3, 4, 5 of those systems that starts to infect other machines eventually infect all of the machines that are able to be infected. Bluster was really a blast for us trying to prevent. So we introduced IPS at the access layer in order to prevent this from happening again. So this is one of the examples, and when companies actually comes and talk to you and say, well, we need to implement that at the access layer, that's something that's worth thinking about. If we want to have a wide deployment, it means that we need multiple sensors. There are a lot of moving parts. That's another weakness. We can't actually monitor for services because we cannot monitor idle services. We cannot monitor state changes. If I just enable a certain service and nobody connects to it, I'm not going to see it. And of course, it means that it can be there or it cannot. A good example for that is Windows 2000 installed by default. IS5 is being installed. If you have that in your environment and you have a passive network discovery system, this is not going to be discovered by anything. So, these were the obvious weaknesses. Questions from the tired audience? Yes? Based on traffic, basically the question was, do passive network discovery systems can detect not enabled devices, right? As you will see further ahead, part of my research for for this presentation, and it took me actually 3 years to research this. All of the research that is out there for detecting not enabled devices is working for around 60% of the times. In the real world, when you have thousands of machines and thousands of applications, at the end of the day, it doesn't work. Everything that was basically published will give you too many false positives. Yes?
In the face of passing TTL, are you making the assumption that everybody starts their TTL at the same point?
No, that's a good question. I'll show you an example in 2 slides. Okay. So, the biggest problem of passive network discovery system is that it cannot resist decoy and deception. Basically, passive network discovery needs to believe to what it sees. Even if the passive network discovery has some kind of remediation policies and it can verify several things, it still cannot resist decoy and deception. So it is very, very easy to tell a passive network discovery it is something that is not actually there. Try to just simple attack. Take a sniff, use TCP replay, and a sniff of another network, and just play it near a passive network discovery system. You don't want to see the results, believe me. Another thing is that since passive network discovery systems do not have any way to validate the information, then it needs to rely on the information, and it cannot actually say if the information is true or false. So we can easily influence those systems. I'll show a very, an easy example to understand in just 1 slide. But the matter of fact is that if those systems are deployed to provide with context to other systems, like there are some companies that actually do this, then the information that will be provided by those passive network discovery systems to those networking and security systems will be inaccurate. So, let's see an example. In the right corner, wearing blue shirts, we have a Windows system. A Windows system by default has a TTL of 128. So let's say that I want to falsify that information and decide that I want a default TTL of 126. If you recall from our previous network slide, this is exactly what we see. This is our network. But since we have played with the TTL, even if the passive network discovery system decides to take the TTL information and use it only after it detects the operating systems and saying, okay, this is a Windows machine, and we know that the TTL is usually 128, so if we see the TTL goes by a range of 10, let's say between 118 to 128, then it's okay by us. This is the result. I just moved the system 2 hops down by doing nothing. I just went, I changed the TTL, and there is no way in the world that the passive network discovery system is now going to tell me this is not the truth, because it already identified the OS, all the parameters are fine, just played with one of them, and is still in range, so I just took it and move it down. This is a very simple example, but there are many other examples that can be used. One of them relates to network utilization information. One of them relates to the way information is being gathered. But at the end of the day, when you are not able to validate the information that you are collecting, there's no way that you can provide accurate information. Yeah, of course. Take a tool that is able to inject with network traffic, and there are several tools that you can just put scripts, and they will inject the kind of traffic to the network, and you can build your own networks virtually. This is exactly how a couple of companies do test beds. They have tools to generate traffic, and they mimic WAN or LAN traffic. You put that there, and that system is dead. Other weaknesses: sniffers can be crashed, various denial of service attacks. The last big one against North was playing around with the TCP/IP options. Another issue is even remote code execution, which usually Ethereum, which is a great tool, stars in that category. Questions? Okay. I mean, during lunch it wasn't that much food. I mean, okay. As I said before, well, I'll ask, how many of you do, well, I guess all of you do network security, but how many of you are actually chief security officers, CIO? No one. Wow, okay. So I was working as a chief security officer, I was working as a consultant. Basically, I did all the work that can be possible with network security, well, except for working as an analyst, but this is not the work, right? So one of the biggest problems that I had is to come to a network, to understand what's the network, and to try to give the company that paid for my services, or my own company that was in charge of security, an added value because I understand what I need to defend. Unfortunate, there is no tool that actually can do that, because when you need this kind of information, when you're saying, okay, I want to deploy more firewalls, I want to deploy IDS, I want to deploy IPS. Usually, the people will understand only one point in their network, maybe 2 points in the network. One is the point that actually connects them to the internet, because they can actually go to the server room and they can put their hands on the router that actually connects them to the internet and to that firewall that they usually maintain. And of course, the point that they're being connected to other networks using several B2B links or whatever other services they're using. Usually the enterprise network, all that you can see, all you can understand about is that we bought those 6500 several years ago. We have 2 of them because Cisco told us that redundancy is a must, and we have some access switches and everything is connected nicely, but other than that, there is no knowledge about what is actually there. One of the funny stories that I always tell is that I went one day to a company with not many elements on their network. They had around 500. And I found out that they have a Windows 95 machine operating on the network. And they were saying, oh, this actually can't be. You don't have Windows 95. You're hallucinating. Well, I said, okay, let's go to the switch, to the port, which I told you this system is connected to, and let's see what we have. Apparently, they have a security guard that has a post which is around 15 meters from the corporate headquarters. In that post, that security guard, because he's, people are not coming all the time through the gate, he has a computer where he plays one of the best ever games, Solitaire. And the machine runs Windows 95, and it is connected to the main IP network. So you don't even need to enter the building if you want to do something. All you need to do is to take out the guard, and you are in the network already. At the end of the day, there is a need to understand what we have, because as I said before, and this is my mantra, if we don't understand what we have, we can't ever secure it or manage it. During my course of research, which took around 3.5 years, I've taken any kind of network discovery technology, basically active and passive, and I deploy that, I play with that, theoretically analyze that. And I found out that at the end of the day, most of the technologies, they fail to deliver. There are several companies that do a lot of money because they sell these kind of solutions, but at the end of the day, if we really want control, we can't get control using those systems. Per your question before regarding the NAT devices, I tried everything that is written in the papers, the Belvin paper, the papers that follow that. At the end of the day, it's 60-40, 60 true, 40 false. And the 40 false, sometimes it's ugly, sometimes it's more than that. So you can't really deploy something that is based on these theories. And I've also found that some of other mapping abilities or theoretical articles about this, about that, can't be really deployed on a network that have thousands and thousands of devices. So I set my goals to build a network discovery technology which will first be complete. I'd also like it to be accurate, you know. I just want the information to be right. I want it to be real time. I don't want to use agents. I want it to be safe to be executed against the production environment. I want it to have a change detection mechanism, so I will be aware of what is happening on the network, so I can be able to do strong auditing throughout my network. And of course, just to do small things to resist decoy and deception, and to allow me to do that throughout my entire environment. The solution to all of this is called dynamic infrastructure discovery, or a new term called dynamic network discovery system. Basically, a dynamic network discovery system is a system that can overcome the limitations with active and passive network discovery and has new abilities when it performs discovery. It is adjustable to any kind of networking environment, and it not depends on what you're going to see throughout the network. In order to understand how it works, I have this slide. Basically, I can use x86-based servers with two networking cards. One of them is passive, the other one is active. You get network traffic that goes through a top point of the network, as of passive network discovery system do. What you do with the information is you start to build profiles of elements that are discovered through the usage of passive network discovery. You build those profiles, and you mark those elements that either you need to verify some details about, you mark the missing pieces, and then what you are able to do, you are able to instruct your active card, which is also connected to the same monitor network, to surgically probe for missing pieces of information. So at the end of the day, when you combine between passive and active, you're not only able to have a complete solution, you're not only having the ability to uncover those firewall devices that are not answering to any probes, or those machines that do not want to send you the information, or those machines that are idle on the system, you are able to completely discover whatever you have there. Yes, first question. This is possible to be done, but it's a question of what you define as a network, and there we go into the discussion of where is our perimeter, which is basically gone. You're able to some extent discover those machines as well. It depends on the location of the system. It depends on other parameters, but you are sure able to do that. The ability of the system to operate means that this is a distributed system. It means it needs to operate in different locations because it looks at traffic between layer 2 and layer 3. And only when you look at traffic between layer 2 and layer 3 are able to uncover several things that are really nice to understand about your network. And it means that, for example, if you have small offices or things like that, you have a smaller system there, or you can just run it on a client even. So you have a complete coverage. That answered your question? No, you'll see everything, because if it's connected through that network, you're able to see it. If you are at a choke point that shows this, then you're able to see it. It all matters, the way the system works is by looking at the actual network traffic for the monitor systems that you would like. So for example, if this is only simplifying the architecture. If you're connected, for example, to a core switch and you're able to span multiple networks, that's fine, but sometimes you have to do this for a remote location as well. The system would work fine for those monitor networks and would be able to ask questions for those monitor networks.
Let's say that was the firewall VPN. On the outside of the firewall, we detect how many VPNs are on the outside of the firewall.
No tool can able to detect how many VPNs you have unless the VPN allows the remote networks to have their own IP address when they connect to the network. So if you're running, say for example, checkpoint with office mode, then you're able to detect that you have local IPs that actually are on the network and you're able to observe all of their traffic. If the firewall is performing NAT for those VPN users, then currently there is no way unless you connect to the firewall to tell the exact number of devices that actually connect to the kind of information that can be collected using dynamic infrastructure discovery technology. Well, basically it's everything, because you can use either passive network discovery or active network discovery in order to collect it. It allows you to completely collect information about the network elements, their properties, the network services, whether they're active or idle. It also means that you are able to have a physical network topology and not just the layer 3 topology. Enjoys other abilities that are either inherent with passive network discovery or either inherent with active network discovery. The usages, you can do whatever you want with the type of information that is being collected. Basically, when you have real-time information about your network, which is maintained in an accurate and complete manner, you can build context about your network. Context that a lot of tools, at the end of the day, try to have in order to secure and manage your network. For example, asset discovery, your physical network topology, you can monitor changes in real time. You can have extensive auditing, which is being done passively and actively. You can combine tools that can have multiple meaning to them. For example, if you detect a new device on the network, you don't need the networking equipment to tell you someone had connected to the environment, but you can now do it yourself. You can detect where it is actually connected to. So if we look at the strength of this technology, since it is combined between passive and active network discovery, it's able to operate in real time. It's able to detect all of the devices that operate on the network. It doesn't require any kind of engines. It's able to validate information that is being gathered from the network, and therefore it is still able to resist decoys. It's also adaptive. Adaptive in the means that whatever passes through the passive link, the technology can balance that with the active means. It means that, for example, during nighttime when most of the users go away or go home, and there are some desktops that are still operating, and the users didn't shut them down, the system might need more traffic in order to detect that they are there, because there is no active network activity that coming from those systems. But still, the balance is being done between the amount of traffic that needs to be sent to the network according to the type of information that is being seen from the passive side. Another thing that can be done is to do change detection, since this is usually something that relates to passive network discovery. You can also combine between discovery abilities, and to show, for example, one of the nice things that this technology can do is you can actually show which VMware guest machines are behind which VMware host machines, and it can tie the guest machines to a certain host machine, and it can show that as well. And of course, you can control whatever aspect of the discovery you would like, because if you're not doing that, you might overwhelm the network. And you can also triangulate the user location, the user itself, and the host, so you're able to detect exactly who did what on your network. Since the active probing is surgical and uses traffic that is not going to harm production, you can use the technology against production machines. And of course, it provides you with granular network performance information and can overcome all the limitations that we've been talking to. Although it has one limit, which is the inability to scan all of the idle services, because this is a definitely no-no scenario to do with any kind of tool. Questions? Yes? Triangulation means that, well, I came with this term from the voice over IP world. You can take the username, and take the host that it is being using, and the location that this machine is at. And it means that the host name identifies the machine, the user identifies the user using it, the location tells you where it is. If I was switches. When you're doing physical network topology, there's no way in the world you can do that without querying the switches. If you have, I always joke about this because if you don't have some kind of telepathy, then tools like Passive Network Discovery cannot tell you exactly where these things are. Other questions?
Does it handle VLANs?
It handles VLANs, yes. Of course, if it doesn't handle VLANs, then what's the use of it? I mean, most of the traffic that new networks that are being built, you'll see VLANs. So, other question?
Your description of surgical active discovery there implies some intelligence to prevent the crash. Can you speak to that a little bit?
Yeah. During my Expert 2 work, I've experienced with a lot of tests that actually will take an element down after you do a probe. Sometimes if you have, for example, old print servers, and you try to scan them, and you send the information too fast, just tell me what the ports that are open, the device will crash. Why? Because it was built back in the days, 5 years back, 6 years back, and it can't handle the kind of traffic. So what the balance is that some of the information about the element is already known because of the passive side. And there are a number of X tests that needs to be done and combined together between passive and active if the information is not seen or if the information is seen but you want to validate it. Each and every of those tests, when they are fired against the element, will never cause the element to crash. It's either because there is a gap between the timing that you send the probes, because the probes are legitimate probes, and it's also because the probes, at the end of the day, were tested because a lot of people use different tools that I have analyzed or that I have been using for myself.
On one extreme, then you would never fire an active against something you didn't have to be so passive.
No, I will validate the information somewhere, some way, and I will look for consistency with the information. I will not go and say, okay, this device told me that he is really what he's telling me, and I'll believe that forever. Because if I'll do that, then all the tricks that we talked about earlier regarding replay information and doing decoys and deceptions will never work, because the tool will be useless. So you have to validate the information that you take from the network, and then you need to say, okay, I at least have X number of tests that I can use. Usually it's one or two, nothing more than that. It means one or two packets that I validate the information with, and then I can present you with information that is actually validated. So what you can do with this kind of tool, at the end of the day, you can have control, and that's the name of the game. You can have visibility into the infrastructure. You can detect anything that is actually working. The research had gone to the point that the accuracy level of detecting properties and operating systems is, we have actually less than 0.25% of false positives. The ability to instantly locate any offender, the ability to instantly locate any machine, The ability to instantly understand where that machine is connected to, how the physical network topology looks like, to track through changes like, did my active link went down and my redundant link went up, and my switch connectivity changed because I connected the switch and now it's the root bridge for the environment. Now all my traffic routes through somewhere that don't actually go nowhere. Those are kind of changes that think about your environment, think about the problems that you had in the past 6 months. You'll understand that most of the questions, most of the answers, rely on the ability of you to get this information when you have the problem. Or when you want to defend your environment, you want to understand how many devices do I have, or did I deploy this kind of patch throughout my environment. Currently, if you use, for example, a patch management system, then it might work against all of your systems inside the domain, but what about all those systems that R&D, that QA might use? So again, we come back to the 80-20 rule and how do we solve it. And the way to solve it is to understand what we have. And it's not only it's not only about the clear visibility, it's about the information that you can use. So if you are able to understand what you have, you are also able to understand if you have something that operates on your network, if it actually does not need to be there, if there is someone that had connected something to the network that shouldn't have been there in the first place. And of course, you can use the kind of information that you collect from the network to any kind of vertical application afterwards. If you want to do what I term as target-based vulnerability assessment, let's say I want to do assessments against my Windows XP machines only, or I want to do assessments against my Linux systems only. Today what you need to do, you need to fire your vulnerability assessment tool. It needs to do a lookout throughout your environment. It needs to detect the elements against, again, 80-20. And then it will have to do the vulnerability assessment. We can cut this time to minimum because we already know what we have. So if I feed that information directly to the system that needs that information, it means that those systems can actually do the work that we actually bought the system to do. So, as a summary for all of this, if you have any other questions that you would like to ask, yes. Of course it exists. If I wouldn't talk about the technology, it doesn't mean that I actually tested it and use it myself. I never talked about something that is vague and, If you want to ask, this is not something that I'm going to talk about here. This is not a conference about products. Other questions? Yeah.
So you ran it on some network. I'm curious how long you feel you can run before you're confident you complete that.
The research took 3 years. So it means that during those 3 years, and of course I have previous research done with Xrub 2 and other tools. The research itself went through 3 years before I even decided to do something with the technology. Before I felt that this is something which is a viable solution.
I mean, since you got the passive aspect and the active electronic balance all up, I'm just curious, if you run it for a week, a month?
How long it takes to see the results? 15 minutes. Yes? At the end of the day, if you look at the network traffic and you have audit-based information, then you are able to see patterns within that information. Yes? We're still able to detect the switch, and we're still able to tell the switch doesn't answer to SNMP. So we can take... No, but if that Netgear connects multiple machines to one port in another machine, then we're still able to say, well, you know what, there is no ghost connecting those other machines to the port. There are no false positives there.
You said you basically listen on the line or you as little invasive as you can. So I assume you
Currently, I'm not, I'm not after the exact Apache version. I'm not after exact IIS version. I'm just after that the service is running on this machine. The service is running on most of the services will run on default ports, but if I find a service that runs on port 55555, there's something wrong in that machine. I don't need to be a genius to just understand that someone is now playing with this machine and shouldn't do the things that he's doing with it. The understanding behind it is that just let me understand that something is wrong, and I can call IT, I can call help desk, and they will play with that guy and they will see what his machine has, because you just need to be aware of that. Okay, thank you. Yeah. Sorry? Because you need to disconnect the cable, and it means that you can't do that in regular operation hours. And I like to sleep at night, so. Yes.
On your OS 6, are you going down to the
Versions. Yes.
To clarify, using the term surgical, is trying to reduce the amount of active scanning required
It means that I don't send a lot of traffic to the element in order to get the properties that I need from the element. It means that it will be minimal packets that needs to be sent to that element in order to detect the information that I need. If I don't see the type of information that I'm looking after in the passive stream. Okay, so thank you for having me here, and have a great day.